Okay, question 2. Write a balanced molecular, complete ionic, and net ionic equation for this process. What I always like to do, and I'm going to do these in different colors just so you can kind of see my thought process, is what I usually try to do is I label the elements on both sides. And by sides, I mean I usually break down like a line, a line where the arrow is to show that now, I'm actually going to write the same thing on both sides so it doesn't confuse you. That from on the reactant side of the equation versus the product side of the equation, that we still have the exact, same thing. When I look at this equation, I notice that on one side there's 2 hydrogens, and on this side there's actually 3 hydrogens. And really what that tells me is there's going to be a difference that I need to figure out, specifically with the hydrogens being this one 2 and this one 3. What I'm going to do personally is I notice that if I put a 2 right here, I'm going to have 2 sodiums, 2 oxygens, and instead of having, the 3 hydrogens from before, I'll have 4 hydrogens. And I think that makes it a little easier for on the other side, if I just put a 2 right here, then I'll have 4 hydrogens and 2 oxygen. And I just want to say for this to kind of work, really it's just taking this and multiplying it on these elements. So that's going to be like 2 times 2, which is 4, 2 times 1, which is 2, 2, 2, 2, 2, and that's how that works. I'm going to erase my little underlines because we don't really need them anymore. And so from that point, I notice that I have 2 chlorines right here, and on this side, I have 1 sodium, 1 chlorine, but that can easily be remedied if I just put a 2 right here. So that would make these 2 sodiums and 2 chlorines. And so now we have a balanced molecular equation. What I always like to do afterwards is I erase what I have here, and I go back through the equation to double check that I have the same on both sides. So here I have 2 sodium, 2 chlorine, 4 hydrogen, and 2 oxygen. And then we already know on this side we have 2 sodium, 2 oxygen, 4 hydrogen, and then 2 chlorine. So they both equal the same thing. I'm going to erase these now. And in a different color, I'm going to pick purple because I like purple. Erase these 2. And I'm going to do the complete ionic equation. Now, what I'm going to put is I'm just going to put ionic right over here. So then we know that from here, we're going to be doing the ionic equation. The ionic equation, we're really going to be breaking down these aqueous compounds over here because we can't break up a liquid or our gases. So we're just going to be breaking up our aqueous compounds. And how we would do that is we would, take 2 sodium. Sorry, excuse my dog. He decided to leave. And we also know that we have 2 chlorine right here. And that's because this 2 transfers over, like I said before. What I'm actually going to do is I'm going to add in our aqueous. We know that these are both aqueous. And we also know that sodium has a positive 1 charge and that chlorine has a negative 1 charge. And that's why when we have sodium chloride together, it's a 0 charge overall. Then I'm going to move over. I'm going to say that we have 2 H2O in liquid form, And these usually, it's usually balanced out for our hydrogen, so we don't have to break that up anymore. Now we have to go to our product side. I'm going to write electricity at the top because we want it to just, we want it to just follow all the way down. So now we have our sodium, that's aqueous. It also has a +1 charge. And this time, instead of, breaking up our OH like we would usually, we need to recognize that this OH is actually hydroxide. And so we have 2 hydroxide ions that are aqueous, or 2 hydroxide compounds. And so that's going to be a -1 charge. We also have H2 in a gaseous form and Cl2 in a gaseous form. I'm sorry, I don't know why I made that G or this so big. But as of right now, we have a complete ionic equation. I'm going to change my pen to pink because I like pink. And we're going to do our net ionic equation. I don't know why I highlighted equations. Net ionic. I'm going to put net ionic just to remind us that this is what we're doing next. And I'm going to look at my full equation and realize that I have sodium on both sides. Now, when it comes to our net ionic, it just means that we can get rid of the things that are on both sides of our equation. So we're going to get rid of our 2 Na aqueous. And what we're left with is 2 chlorines, 2 chlorines, 2 H2Os. We're left with 2 of our hydroxide, 2 hydrogen gas, and 2 chlorine gaseous. And from there, I know some of us are going to be like, oh, well, we have 2 chlorines on both sides. Unfortunately, we cannot get rid of them. And the reason we can't is because this chlorine is aqueous and this chlorine is gaseous. And because they're in 2 separate states, it means they are technically in 2 forms. And we can't get rid of that on both sides. So what we're going to be left with is 2 Cl, -1, aqueous, plus 2 H2Os, liquid. That through electricity, which I'm just going to rewrite it because I like having it carry down. We know that we canceled out our sodium, so we have 2 of our hydroxide, which hydroxide is a base. It is one of the bases that you are going to use quite a lot if you continue your chemistry career, and I just think that's neat how we have that in this problem. Anyway, we have our 2 hydrogen gas and our 2 chlorine gas. And from there, we have our net ionic equations.